How's everybody doing? We're Group 1 and we will show you our project, which is called ANVIS, which stands for Automotive Night Visioning System. If you follow me, I'm going to show you all the different components for it. Right here, we have one of our cameras which will see all the right side blind spots. Up there, we have certain illuminators which will help with night visioning systems. If you follow me back here, we have the rear view camera, which will, of course, see what's in the back. And if you follow me over here, you have our left camera. And up here, you can easily see our front view camera.
And take it inside real quick.
Exactly. Now if you come inside, we have our display right here and what's powering our board all through here. We're using a Jetson Nano.
I'll take that.
A Jetson Nano to work with everything. And our Jetson Nano is powering all of our cameras as well as our LCDs, which is one right here. This is for night and this is for during the day.
Power is coming from the PCB down there.
Our power is being led through this PCB, which is powering the Jetson, of course, and it's coming from, we will show this right now,
The car battery. Careful, it's probably gonna be hot. So we got a fuse tap right here. Takes power from the car battery. Car battery is outputting 12 volts, and then our switching regulator down converts it to 5 volts, which is what the Jetson Nano runs off of. Okay, so now that we've gone through all that, right now you can see, the code actually aired out. So we got the code running right now. Our entire system is voice activated, so we use voice commands to turn all the cameras on and off. We also have the OBD functionality plugged in down there. What that does is it tells you, we have it telling you your RPMs, your speed in miles per hour, and also any error codes that might trigger the check engine light to turn on. So we'll start with showing you each of the cameras. ANVIS, back camera on. So as you can see, through the voice activation, we were able to turn on the back camera. ANVIS, back camera off. And it turns it off. ANVIS, right camera on. There's the right camera, and that's our group member Evelyn over there, you can see. ANVIS, right camera off. ANVIS, vehicle camera on. And that's the front camera. This camera is mainly supposed to be used at night, so it doesn't look that good right now because it works in IR, but we'll do a separate demo. We'll do later on in the demo, we'll show you what it looks like at night. ANVIS, vehicle camera off.
ANVIS, left camera on. And as you can see, from the window rolling down and me waving outside, the camera is working on the left-hand side.
All right, now turn it off.
ANVIS, turn off. Perfect. Now, if you want to see the latency of how quick or how slow the cameras work, we can show you that right now. ANVIS, back camera on. As you can see, it's maybe a quarter of a second.
Mm-hmm.
Very fast, very quick, which is what you want when you're dealing with this type of technology. You don't want to be sitting in traffic, looking at your left-hand side, and it takes 3 seconds to turn on. So we were able to get this down really quickly. And it's the same speed for all 3 cameras.
Yeah, and also I just wanted to say, so ANVIS, left camera off. Or what was the back camera?
Hold on one second. ANVIS, back camera off.
ANVIS, turn the boss on.
So as you can see, the OBD is relaying the RPMs, shown here as well as here, our miles per hour.
If you could rev it, you'll see that they change. And then, do you want to drive so they can see the
And we'll show you the speed real quick.
Yeah.
We're going like...
That's in miles per hour.
Yep.
So yeah.
Now we're coming to a stop. Now we'll reverse back.
And you can also see that there is, in fact, a check engine light on, and this is the air that it's giving. Oh, it's out of focus. So we got an evaporative emission system leak detected, a very small leak. So it's up to the user if they want to go and fix that, but we're just telling them what it is. So you can actually talk and like say things and not trigger the system, because you have to say "and" before you say anything. So I can say left camera on, or right camera on, or back camera on, and it won't turn any of them on unless I say "Anvis back camera on." And there you go.
And you can see there's a car behind us that we didn't see from our from our mirrors, so
Yeah.
that always helps. Anvis back camera off, and it turns it off. So
Yeah. And what else is there? I wanted to mention that the voice recognition works completely offline. So as you can see, like the Ethernet right there,
which is right here, this silver piece.
yeah, we don't have anything connected to that, and there's no Wi-Fi capability on board the Jetson Nano, so we had to work offline completely. So our voice recognition is working offline. That does affect the accuracy, but as you can see, it works pretty well.
If you were to be connected online with a more expensive processor, you could easily use different algorithms that would make it 100% accurate.
Yeah, different speech APIs like Google or
Amazon,
IBM. Yeah, so all those work online though, but they are more accurate because they have access to cloud databases, which are a lot bigger than the storage capabilities that we have. So yeah.
So, as you can see from our backup camera,
one of the specs that we wanted to show was how far back you could see, like what was the minimum distance you could see, and then how far back from that you could see while still being in focus. So we chose our focal length so that you could see at minimum 5 meters behind the car. So this line right here, that's obviously like the shortest point you can see, and then all the way back where Carol is, that's 5 meters. And then you can see a lot further back, but we just wanted to specify that it's supposed to at least be 5 meters. So if we go outside and we can look at the lines better. This is the first line, the shortest line that you can see. That's the 5 meter mark. So for our side cameras, we wanted to basically show the blind spot, right? So a lot of times when you're driving, you have to look back like yourself, like turn and look, just check your blind spot because you can't see it with your mirrors. So we wanted the camera to be able to see the blind spot so that you didn't have to turn your head away from the road. And so to do that, we had a minimum viewing angle of 60 degrees. We actually ended up hitting 77. And then what was the distance again?
minimum of 5 meters. And
minimum of 5 meters.
And that's where Carol is standing right now?
Yeah, so that's 5 meters. So we chose our focal length for the camera to meet those specs. And as you can see, we've met them. You have anything else to add?
No.
And these specs are the same for both side cameras. So right now we're showing the left, but the same is true for the right.
As you can see, we have the projector outlining the person on the road. It perfectly overlays them so you can see them. This was created by the projector using as our image source, which then reflects off of the mirror down into the lenses. We use two meniscus lenses, to magnify the image. As you can see, when I take one of them out, the image size gets smaller than when it was before. As you can see, the image is smaller when without the lens, and it gets bigger with the lens. See? And we use that because we're limited in projection distance. And going back from the driver's view, you can see that the outline of the person is much brighter than without.
So as you can see, our display size is given here, which is 14 by 10. And this display is literally the same thing that the driver is seeing. So the minimum distance we required is 10 meters. And starting from the car location all the way to the user is, as measured, 10 meters. And as you can see from the video captured, you could clearly see what you're seeing. Now, our degree of viewage was specified to be 60, but due to our selection in camera, we were able to get it to 70, which was much better than what we previously required. One more thing, as you can see, this LCD is reflecting off the windshield, which is acting as another hub. At night, you can clearly see it, but during the day, due to the reflection of the sun, you can't see it. So this will be used only at night, and it could help with showing the OBD information and other specific things.